Dear students, welcome to Learning Management System, Department of Collegiate and Technical Education. The subject is Analog Electronics, Unit number 6, Op-Amp and Timers. This is the session number 50. Myself, Mon Kumar MR, lecturer, HMS Polytechnic, Government Aided, Tumkur. The topics that are to be covered in this session are working of low-pass filters, application of low-pass filter, working of high-pass filter, and applications of high-pass filters. Before going for today's session, let me have some quick recap over a previous session. In previous session, we had a discussion on the filter definition, that is, filter is a circuit that designed to pass a specified band of frequency while attenuating all the signals outside the band. It is the frequency of selective circuit. Filters means almost for all communication system we use filters. The desired signal is often mixed with noise. ಅಂದ್ರೆ the filters ಅಲ್ಲಿ the signals is comprised of noise, and the extraction of signals from unwanted signals can be done by some of the frequency of selective filters or selective circuit. The filters actually, it passes one band of frequencies while rejecting the other. Again, these filters is further classified as the passive filters as well as active filters. Now, the active filters means it uses the active elements such as op-amps, transistors along with the resistors, inductor, capacitor. Here, the active filter, it is a type of analog filters which uses the active components such as transistor, op-amps, along with that the passive elements like electric signals which are specified band frequencies. It's called active frequencies, active filters. The active filters are useful for below less than or less than 1 megahertz. And for passive filters, actually, the passive filters means the passive filters are built with the passive components such as resistors, capacitors, and inductors that passes the electric signal or a certain band of frequencies that blocks the other frequencies. The generally which are is meant for above 1 megahertz, and there is not having any power gain, and or relatively it is difficult to tune them. This is called about the all active as well as passive filters. This is all about the previous session. Let me go for today's actual session, the working of active low pass filter. Here, the circuit diagram consists of the low pass filters, that is having, this is the low pass filter unit. Here, for this, we're going to have the input voltage, it is for FC, that is equal to 1 divided by 2 pi RC, and for this we have connected a resistor, that is R, and along with that we have C capacitor. This is the capacitor. This is the non-inverting unity amplifier. This is the amplifier which is of non-inverting type. Here we are giving input signal and it is not going to invert. The output of the non-inverting amplifier is same as the input. Here we are going to measure the output. This is the input side and this is the output side. In between that we have connected the non-inverting unity amplifiers. Here in this circuit, the most common and easily understood active filter is active low pass filter. Here, the active low pass filter actually it provides a constant output from DC up to the cutoff frequency, and then it is passed to no signal above that. The frequency is called ideal low pass filter. Actually, the ideal frequencies that a filter has a constant output from 0 to cutoff frequency, and after that the frequency FC, that is the output is 0 as shown, and the op-amp is wired to work as a voltage follower. The main reason for using op-amp is that RC filters can be isolated from the low RL, which may have very low impedance. The RC filter is effectively isolated from the low RL. This is about the active filters, and let us check how it works. It works on the principle of operation, and a frequency response is exactly the same as those of previously seen passive filters. That is, the low pass circuit passes only the low frequency range, and for the high pass frequency it passes high frequency range. The principle of operation of frequency response is exactly same as the previously seen in passive filters. That is, the low pass circuit passes only low frequency range, not high frequency range. The circuit allows the range frequency from 0 to F maximum FH. The output is constant up to Fc, and beyond Fc the gain does not increase immediately to 0, but it reduces with a slope of 20 dB and a dB per decade, and reduces a factor by 100 when the frequency increases by a factor of 10. The active low pass filter is realized by the RC circuit, which is used along with an op amp used in non-inverting configuration, and in the above circuits diagram it is mentioned. This is the circuit diagram which in that it has been mentioned. The advantage of this configuration is that the op-amps are highly input impedance, and it prevents excessive loading of the filters of the output, while its low output impedance always prevents the filters of cutoff frequency points from being affected by changes in the impedance of the load. Let us come for the application of low pass filter. The low pass filters are used as filters in audio speakers to reduce the high frequency noises, and the low pass filters are used uh, in equalizer, that is audio amplifiers, and the low pass filters are used in analog to digital conversion, and also the low pass filters are used in analyzing the filters to control the signals. In count, the low pass filters are used to filter the high frequency signal from transmitting the sound, which will cause echo at higher sound frequencies. ಅಂದರೆ ಲೋ ಪಾಸ್ ಫಿಲ್ಟರ್ಸ್ನ ನಾವು ಆಡಿಯೋ ಸ್ಪೀಕರ್ಸಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಟು ಇನ್ ಆರ್ಡರ್ ಟು ರಿಡ್ಯೂಸ್ ದ ಹೈ ಫ್ರೀಕ್ವೆನ್ಸಿ ನಾಯ್ಸ್ನ ರಿಡ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ಆಡಿಯೋ ಫ್ರೀಕ್ವೆನ್ಸೀಸಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದಿಸ್ ಆರ್ ಆಲ್ಸೋ ಯೂಸ್ಡ್ ಇನ್ ಈಕ್ವಲೈಸರ್ ಆಫ್ ಆಡಿಯೋ ಆಂಪ್ಲಿಫೈರ್. ಇದನ್ನು ನಾವು ಆಡಿಯೋ ಆಂಪ್ಲಿಫೈರ್ಲಿ ಈಕ್ವಲೈಸರ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿರ್ತೀವಿ. ಮತ್ತು ಅನಲಾಗ್ ಮತ್ತು ಡಿಜಿಟಲ್ ಕನ್ವರ್ಷನ್ಗೆ, ಅನಲಾಗಿಂದ ಡಿಜಿಟಲ್ ಕನ್ವರ್ಷನ್ಗೆ ಲೋ ಪಾಸ್ ಫಿಲ್ಟರ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ in order to control the signals. And also low pass filters are used to filter the high frequency signal from transmitting sound, which will cause echo at high sound frequency. Echo cause ಆಗ್ತಿದ್ರೆ ಇದನ್ನ ಲಿಮಿಟ್ ಮಾಡೋದಕ್ಕೆ this low pass filters have been used. The working of, if you come for a working of active high pass filter, a filter circuit that provides a gain or an output zero for frequency below cutoff frequency, that is Fc, and has a constant output beyond Fc is called ideal high pass filter. Usually, in the principle of operation, the frequency response is exactly same as the previously seen in passive filter. That is, high pass circuit passes only high frequency range, not low frequency. Here, the circuit diagram is similar to low pass filter. It consists of input voltage, that is Vin, that is for a high pass filter stage, and capacitor is connected along with the resistor R3. Again, the amplification is done through the amplifier, that is non-inverting amplifier, which is of high frequency range, and by connecting the resistors R1 and R2 to the amplifiers, which will make the circuit to give the purest amplification. The circuit allows the range of frequency from FH to above. The FH means the frequency of the filter, high pass filter. The active high pass filter is realized by RC circuit using with an op amp, and it is used non-inverting configuration as shown in the circuit diagram. For non-inverting amplifier circuit, the magnitude of the voltage gain for the filter is given as a function of feedback, and also the resistors are divided by its corresponding input resistor, and the value is given as a gain for the active high pass filter. And for the frequencies of active high pass filter is normally about Fc is equal to 1 divided by 2 pi Rc. That is, a voltage gain is equal to AV, V out divided by V in, that is equal to AF into F divided by Fc divided by root of 1 plus F divided by Fc whole square, where AF is the pass band gain of the filter, that is equal to 1 plus R2 divided by R1, and F is the frequency of input signal in hertz, that is uh, Fc is equal to the cutoff frequency in hertz. F andre pass band gain, F andre frequency of input signal, Fc andre cutoff frequency in hertz. Let us move for application of high pass filter. In high pass filters, the speakers are used to filter the out pass from the audio signal, and it is being to send to Twitter. They are also used to remove a DC offset and also DC bias from a signal. In contrast, the low pass filters can be used to filter out the high frequency signal in audio being sent to be subwoofers, and that can't efficiently reproduce the high frequency parts of the audio signal. There are also, it is used in devices such as tone knob of electrical guitar, that is to filter out the treble or an analog synthesis. These are all the applications of high pass filters. The outcome of this session is to, at the end of the session, the student will be able to understand the working of low pass filter, and the application of low pass filter, working of high pass filter, and the application of high pass filter. Let us go for MCQs. That is, the filters are classified as analog or digital, passive or active, audio or video, all the above. Again, I am repeating the question that the filters are classified as option that are given: option A, analog or digital, option B, passive or active, option C, audio or video, option D, all the above. Let's check the answer. That is option B, passive or active filters. Let me move on to second question. That is, the problem of passive filter is to overcome by using analog fit options that are given: A, analog filter, option B, active filter, option C, LC filter, option D, combination of analog and digital filter. Let me check the answer. It is option B, active filter. Third question, that is, what are the most commonly used active filter? Options given are option A, low pass filter and high pass filter, option B, band pass filter and band reject filter. Option C, all pass filter. Option D, all the above. Let me check the answer, what it is. Option D, all the above. Choose the range of frequencies of low pass filter. Options that are given 0 to less than f, which is less than fh. Option B, fl less than f, fl f, fl less than f, which is less than fh. Option C, fh less than f, less than fl. And option D, fl is greater than f, and which is greater than fh. Let us check what is the answer. It is option A, 0 less than f, and it is less than fh. And the last one, find out the incorrect statement about active and passive filter. Options that are given. Option A, gain is not attenuated in active filters. Option B, passive filters are less expensive. Option C, active filters doesn't cause a loading of source. Option D, passive filters are difficult to tune or adjust. Let me check the answer. That is option B, that is passive filters are less expensive. Hope you all understand this session. Thank you. Thank you very much.